Hello, my name is Greg Fridman. Welcome to my journal club. So today I'd like to review a very important, highly cited, very cool paper published in Lancet, which is a very respected medical journal. I can't say very enough about this work. I urge you, if you have any interest in this, I urge you to download this paper. It's free for all. It's open access. And study it for yourself. This is tremendous amount of material, and I will give you a very brief overview of what this is. Stick around for some pretty interesting and very scary pictures. Nothing gross though, just graphs. So this paper talks about global burden of bacterial antimicrobial resistance from 1990 to 2021, a systematic analysis with forecasts for 2050. So the authors, and this is authored by GBD 2021 Antimicrobial Resistance Collaborators. Now, if we scroll all the way down, they didn't want to list the authors up front because there are just too many. So we have to go all the way to the end of the article. And where is it? Here's the list of authors. These three persons contributed equally. They're the equal first authors. So this article has 3 first authors. And look at the rest of them. All of these folks authored this article, and if you're curious about their affiliations, you have to look at the online version of this, and it's detailed in Appendix 3. Anyway, so this is huge work, and it deserves many hours, if not days or weeks of study, rather than a 5-10 minute YouTube video. But let's give it a brief review. So the authors suggest that to date there have been no systematic or as thorough as this one comprehensive estimates of antimicrobial resistance burden across locations that encompass historical trends and future forecasts. So this is a pretty solid claim to make. The authors are trying to assess the importance of antimicrobial resistance and project it into the future. They studied effects of 22 pathogens in 204 countries from 1990s to 2021. They look into 520 million individual records or isolates and almost 20,000 study location years. This is massive. That's why so many people are involved. They look at risks of death or duration of an infection associated with this resistance. And by the way, I love medical journals. They put this 1-page, 1.25-page summary of the entire article right up front. So if you're skimming, all you have to do is skim the first page and you got the whole thing. But there are some interesting details in the paper itself. And finally, the authors produced global and regional forecasts for antimicrobial resistance burden until 2050 for a couple of different scenarios, good, bad, and ugly, sort of. Their findings, if you want summary, you can log off and go watch another video in about 10 seconds. So from 1990 to 2021, deaths from AMR decreased by more than 50% amongst children. That's good news. That's excellent news. That's awesome news. Very happy. But they increased by over 80% for adults 70 and older. So we're keeping our children cleaner, better fed, and so fewer of them are dying from crazy things like multi-drug resistant bugs. But adults are affected significantly more over the years. And their forecasts show approximately 2 million deaths attributable to antimicrobial resistance and 8 million deaths associated with it. So we're looking at 10 million deaths in 2050. that's a number worth considering and thinking about and trying to fix, because by 2050, I will be in that 70-year category. So we better fix this. I don't want to die from this stuff. It looks pretty nasty if you read the paper. And of course, authors conclude the summary, that AMR is bad and big burden by location and age. It is important that interventions combine infection prevention, vaccination, minimization of inappropriate antibiotic use in farming and in humans, and research into new antibiotics to mitigate the number of AMR deaths. Antibiotics or new ways of kill these bugs. Not necessarily with drugs. Maybe we can work on some devices. So here's a business opportunity for you. A lot of people will die if you don't get up off your butt and do something about it. So let's dive into the actual paper. And by the way, you have all the data, 10 million dead in 2050. So that's it. The rest is details. And I am skipping over a lot of details. I'm just giving you highlights that I thought were interesting or important. So like we said, 10 million deaths in 2050. And while this is being heavily debated in the literature, I'm sure that's not my specialty, but estimates like this will be heavily debated still. This debate helps position antimicrobial resistance as one of the most pressing threats to health of the 21st century. Bold claims. Really strong ones. Yeah, the authors also point out that recent estimates indicate that the highest burdens attributable to and associated with AMR are in sub-Saharan Africa and South Asia. However, authors point out that these locations lack historical estimates, so we're not sure what was happening before and why what's happening is happening now. But still, maybe you live in Idaho, but maybe once in a blue moon you travel, especially go to the desert and watch the stars. And keep in mind that there's a lot of weird infection going on around you. So if we don't address it now, it's going to get worse. And also authors point out that other studies suggest that demographics are shifting and the population is getting older. So if we continue overuse of antimicrobials, both in human health and agriculture, that would produce an environment that selects for increasingly resistant bacteria. So things could get even worse. And again, lots of very important details, and I'm skipping over most of them. Things like sample size of 469 million causes of death, input data, etc. It's important to read all of this and study all of the references and appendices if this is your field of study. If you're here for entertainment, cool graphs are coming. So I really liked this figure 1, or liked. I was terrified by it. So if you look at from 1990 to 2021, separated by age, number of deaths. So in 1990, 8.4 million children died from neonatal to 14 years old. Biggest deaths occurring in the first 3, 1 to 4 years, post-neonatal and neonatal. And those numbers are decreasing over the last 30 years. Very nicely, beautifully done. So we're going from 8.4 million to just 3 million. But if we look at 15 to 49, somewhat about, it goes from 2 million to 3 million, fluctuating between 2 and 3. And if we look at 50 to 69, 2.67, up to 6. It fluctuates a lot, and these are COVID years, so maybe COVID has something to do with this. But still, there is an increasing trend, and there's a significant increasing trend, tripling over 30 years in 70 plus. So that's very curious. We're losing access to antibiotics. Microbes are becoming more resistant, and I'm getting older. Uh-oh. Maybe rethink going to the doctor. Yeah, the authors study associated death counts and counts per 100,000, which is, like 100 people and 20 people attributable deaths per 100,000, and 90, 60, 90 by 2050 per 100,000 people. So 100 people per 100,000 will die from AMR. That's 0.1%. That's kind of a lot, kind of scary, especially if you go to the doctor like once a year and get an occasional surgery. Yeah. I don't know why I read these things. They keep me up at night. And of course, it's important the role of the funding source. The funders of the study had no role in the study design, data collection, data analysis, data interpretation, etc. We have repeat. Figure 2 is kind of a repeat of figure 1, just plotted differently, associated and attributable deaths for 1990 and 2021. So we see the green color is 1990 and the blue color is 2021. So we have significant increase in adults crossing over around 20 to 30 years old. So if you're older than 30, present, I would be better off living in the 90s. But if you're an infant, times are good right now. This is also a little bit scary. So this is map of the world with mortality rates per 100,000 people, I believe. Let's check. This is death rates per 100,000 people attributable to AMR. And there are 3 maps. 1990, and we see huge problem in Africa. And Asia is kind of questionable. And if we go to 21, the problem is shifting. And projected problems for 2050 are shifting into China, Africa, the Americas. So right as I'm getting older, that's great. And this is also interesting graph, deaths attributable to AMR by pathogen. So for those 5 years and older, look at this. Acinetobacter, 15% in 2021. E. coli, 14. Pneumonia, if I'm probably pronouncing it wrong, 13%. Pseudomonas, 10. Staph, like staph and strap, common throat infections. Staph, 20%. Strep, 13%. Other AMR bacteria. So staph looks like is increasing. Yeah, methicillin-resistant Staph aureus. Those guys, it's getting worse. Lots of details in this study. The authors also look at the pathogen drug combinations. And for example, for high-income countries like United States, methicillin-resistant Staph aureus. So if you have a staph infection and you're given methicillin, we end up with 31,000 deaths because that staph happened to have been methicillin-resistant. MRSA, otherwise known as the superbug. And again, lots of details here. And people die from E. coli, which is such a benign organism. That's what, E. coli K12 is what you play around with in high school. And then E. coli 0157H7, the food pathogen, kills you if you're given the wrong antibiotic. Scary stuff. And authors spend a lot of time on discussing the predictions for 2050, but in general, predictions are looking worse and worse with no matter what model they use. And again, take a look at this. These are all predictions beyond 2020. Deaths are going up, 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 up. Scary said, we got to do something about this. And goes back to funding for science. We need to increase funding for these kinds of studies. We look at millions of deaths, global versus, for example, sub-Saharan Africa, which authors suggest will be a problematic area in the years to come. Yeah, the authors also noted a decline in antimicrobial resistance burden during COVID-19 pandemic, but that is complicated relationship between COVID-19 and bugs. We were all masked up. We remembered to wash hands. I put a must wash hands sticker in a bathroom. So that could have been it. There are other factors. People could have died from both things and COVID was blamed, et cetera, et cetera, et cetera. In summary, this is a fantastic study alerting us common people who can download and study this paper for free because it's open access, of both importance of scientific studies and importance of correctly spending taxpayer dollars. So a lot of these diseases don't have sufficient funding behind them because the market isn't big enough for pharma to invest billions into the drug development. So this is something that taxpayers should step up, even if only 10,000 deaths. Maybe that's not a big enough market, but that's 10,000 deaths that we could have prevented. Well, I'll leave you at that, and let me know if scary content like this works or not. And also, I started a Patreon page yesterday. I still don't know how to use it. The link is down in the description, along with the link to this paper. I would love it if you join my Patreon. It's free, or I didn't set any payment boundaries, but I think that's a good place to chat, ask questions, and I'm thinking to use that platform to figure out what would be a preferable content for you guys. But you can, of course, leave that down in the comment section. I read all of those and answer the ones that I think should be answered. Anyway, have a good one.